So let's deal with roots now. We're going to deal with square roots. Now, there's no number up in here, but really there is a 2. We just don't write it. So if you don't see a number up in that little corner, it's assumed to be a 2. So that would be a square root. This is a cube root, a third root. This is a fourth root, and a fifth root, and then so on if you go higher. Now, just to start, every real number that you can think of has 2 square roots. There's 2 square roots. Here's what we mean. Let's look at the number 16. Now, there's 2 ways that we can get to 16 using multiplication. Well, at least 2, but here's 2. We could start with a 4, and then what we could do is we could square that 4, and that would get us here to 16. Or we could start with negative 4, and then what we could do is we could write it carefully, negative 4 squared, and that would get us to 16. So this number 16 has 2 square roots. We call it a root because sort of like we can grow a 16 from the root 4. We can grow a 16 from the root negative 4. So 16 has these 2 square roots. Why don't you try this one? What if we take, say, the number 49? Can you get the 2 square roots of 49? One here and one here. So I'm going to claim that the 2 square roots of 49 are 7 and negative 7, because 7 squared is 49 and negative 7 squared is 49. Now, to indicate the positive square root, let's use 16 for an example. 16 we know has 2 square roots. It has negative 7, let's write it up here, negative 7 and 7. To indicate the positive root, to indicate this one here, we're going to put this symbol on the 16. So if we write this, that radical sign, that's going to indicate the positive 7. If I want to indicate the negative 7, to get the negative 7, I'm going to put a negative sign out in front of that. That's going to indicate the negative 7. So every real number has 2 square roots, one positive, one negative. So let's look at 16 here. 16, the square roots of 16 are negative 4 and positive 4, right? Because negative 4 squared will give us 16, and positive 4 squared will give us 16. To indicate the positive square root, here's what we do. We are going to put this symbol, it's called a radical sign, I'm going to put that over the 16. And what that does, that indicates the positive square root of 16. Now, to indicate the negative square root of 16, to get this one, we'll just take the negative of what we just wrote, right? This right here is positive 4, right? That's what we said. Square root of 16 like this is positive 4, so this would be negative 4. So let's see, can you simplify these? What would this one here be? Let's get it to work here. Let's go with the square root of 81. What is that? See if you can get that one. And then what about this one here? What would this one be? Give those a try, and then I'll come back in a minute and see what I get. So what I'm going to get for this one, now this is 81 has 2 square roots, right? 9 and negative 9. 9 squared is 81. Negative 9 times negative 9 is 81. But when I put this symbol on it, I'm indicating the positive one. So this one right here is positive 9. And this one here is going to be, right, this is a 9, right? That's a 9. So what I'm looking at is negative 9. Let's simplify a few. So let's simplify. How about this one? The square root of, say, 100. Okay? We've got the radical sign on it, so 100 has 2 square roots, 10 and negative 10, but with the radical sign, we are indicating the 10. Now, what about this one? Say negative square root 36. Well, the square root of 36, right there, that's a 6. So we're indicating negative 6. So we're going to write this as negative 6. What about this one? What is this? What do you think that is? That's going to be negative 3. Now we're going to write a general statement here about square roots. So if you have something like this, say you have the square root of x. Now, to be specific, And very clear, I'm going to put a 2 here. That 2 is called the index. There's a name for it, and it's a number in the corner there. It's called the index. But if I take the square root of x, this is equal to some other number, y, if y, this number to that power is equal to x. I know it sounds a little confusing. If y to the second power is equal to x. All right, so that's the definition. It says the square root of x, the square root of this number is this number, if this number squared gives you this number. Let's try to clear it up with a few examples. So what if we say the square root of 25, now we know that, that's going to be 5, and that's true since this number to that power, right, 5 to that power, the index, is 25. Let's try another one. What about the square root of 64? Well, that's going to be 8, right? Now, 64 has two square roots, 8 and negative 8, but with this symbol, right, we're talking about the positive one. So the square root of 64 is 8, since this number to that power gives us 64. So let's write it. Since 8 to the 2 is equal to 64. Here's another one. What's the square root of 121? Now, when the numbers get a little bit bigger, like over 100, it's a little bit difficult. It can be a little bit difficult, but once we see a few of them, it'll stick in our heads. So this turns out to be 11, and that's true since this number to that power is 121. Since 11 squared is 121. You can multiply 11 squared out if you like, and you'll see you get 121. Can you figure out this one? It's kind of big. What does that equal to? And it's going to be true since whatever you put in that box to the second power has to be 225. Think about it for a second. Yeah, it turns out that this is 15. 15 squared. 15 times 15 is 225. Now, just like we wrote the definition of square root here, we're going to write one for the cube root. So what we're going to say is this. We're going to say that the cube root of some number x, right, the third root of x, is equal to that number y if, can you guess what it's going to be? If y to the third power is equal to x. So if y to the third power is equal to x. So let's try one here. What can we do with this? The cube root of 8. Well, I'm going to claim that that's equal to 2. Since if I take this number, raise it to that power, let's do it, 2 to the third, I'm going to get this number right here, 8. You can try it, right? 2 times 2 times 2, that's equal to 8. What about this? Can you see what this one is? This is going to be the cube root of 64. What do you think that's going to be? What would you put in the box there? Well, this is going to be a 4, since if you take 4 to the third power, you get 64. Right? That's our definition. That number to that power gives you that number right there. So these might not be too familiar with you, but if you do them a few times, you get to know these numbers. So what are we going to put in here? Well, it turns out that this is 2 because 2 to the 5th is 32. 2 to the 5th is 2 times 2 times 2 times 2 times 2. That turns out to be 32. Think you can see what this one is? What would the fourth root of 16 be? Now be careful. It's not the square root of 16. The square root of 16 is 4. We're looking for the fourth root of 16. So I'm going to say that the fourth root of 16 is 2. And I think so because 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 is 16. Let's try one with a decimal. Actually, how about this? Before we do a decimal, how about the square root of 169? Now this is going to be 13 since 13 squared is 169. And now let's go to a decimal. How about the square root of 1.69? What do you think that one is going to be? Probably related to this 13. Think about it for a minute and put a number in here. Yeah, I think we're going to guess 1.3, and we could say we think so since 1.3 squared is 1.69.